Okay, this is lesson 29. Again, section 5.4, solving right triangles, part 1. And to solve a triangle, it means that you're going to find all the angles and all the sides, whatever you're given. You're going to be given at least two values. And so you're going to be, from that, you're going to find the rest of, the three angles and the three sides. So notice, it doesn't matter which way you draw the triangle, whether you draw it to the right or to the left. Whatever you label it, A, B, C, the angles are usually uppercase letters, and then the corresponding sides, the opposite sides, corresponding sides are always the sides opposite the angle. They're lowercase. So side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So that does matter, okay? But whether you draw the angle, ABC, or if you draw it ABC this way, or if you draw it, with A up here, that really doesn't matter. What does matter is that the sides opposite those correspond to the angles. Okay? All right. Oops. Back. So we take that. So for example, here we have triangle. Now see here they drew it to the left, and that's usually the way I draw it. You have 34 degrees, 30 minutes for the angle, and you have side C in our triangle. So from here, here they're going ahead and finding side A. So side A is opposite over hypotenuse, sine. So sine of 34 degrees, 30 minutes is opposite, which is side A, over hypotenuse, which is side C. So that's A over 12.7. Now, what would we do to solve for A at this point? Travis? Right, multiply both sides times 12.7. All right. And then from there we get 7.19. Okay, so let's see what that looks like on the calculator. All right, so we get our calculator, and so we're going to put in there 12.7. Oops, no, that's 12. Back up. 0.7. Sine. And then we're going to put in there 30 degrees. And so we have to hit second and angle and the degrees. And then 30 minutes. 30 and then second and angle again. And this time we'll hit 2 for the minutes. Okay. Oops, that's 30. That should be 34. So I need to come back here and change that 30 to a 34. 34 degrees, 30 minutes. And so we get 7.19 and it goes on. Okay? And And so we get 7.19. We round that off. Okay? Questions with that? Okay, now cosine, we got 1, so that's side A. We've determined that's 1.79. Now, when you're working with angles, you always want to work with the original values. So here, to find side B, we're going to use cosine. So that's going to be cosine 34 degrees 30 minutes equals to B over 12.7. So we multiply 12.7 to both sides, and we apply that onto the calculator, and we get 10.5. Well, we're still missing one more thing, okay, which would be what? Well, we still have to find angle B. So we just take 3430 minus 90, and we get 34 degrees 30 minutes. Okay, but for this, you have to, let's take a look at that real quick. Here's 90, and then we're subtracting 34 degrees 30 minutes from that. Well, this is all degrees, so we have to borrow. So we know that 1 degree equals to how many minutes? Dylan? 60 minutes, right? So that we got to borrow 1 degree from the 90, so that makes it 89 degrees, 60 minutes. Okay, so now here's our minus 34 degrees, 30 minutes. I don't want to put a decimal there. 34 degrees, 30 minutes. Okay, and so we subtract 60 minus 30, that's going to be 30. And now 89 minus 4, that'll be 5. And 8 minus 3, that's going to be 5. So there we go, we get that 55 degrees, 30 minutes. Okay, subtracting that from 90. All right, questions with that? All right. All right, here we want to, if we could find the measure of an angle B first, then use the trig functions. So we found our other sides by using trigonometry, and then we just, to find that third angle, we knew that from the previous angle that we had 90 in it, so that's 2 out of the 3, right? We had the 3430, but we also knew that one of them was 90. And so we were able to come up with just one more angle. We only need to come up with one more angle. Okay, now this is real important, and this is why I put this in red. To maintain accuracy, you always want to use the given information. In other words, we could have used 10.5. Or we could have found cosine first and used 10.5, and then use tangent A over B and use 10.5. But you don't want to do that. You want to stick with the original values, because if you round off in your process, that could affect your accuracy. So in this case, we want to stick with just the given information in your calculations. All right. If you go off, if you use that, 10.5, then you would have to use the whole thing, and for what we have, it's better just to stick with the given values that we have. All right. Okay. All right, so we got that. All right, we want to solve the right triangle, and here all we have are 2 sides. Okay, so from here we're going to go ahead and we need to find our third side. Well, they went ahead and found angle A. There's a couple of ways you could do this. You could have gone ahead and found your third side, or you could have found angle A first, or you could have found angle B first. You could have done that too. They went ahead and found angle A first. So they looked at sine of angle A, opposite over hypotenuse, 29.43 over 53.58. Okay, so here's your sine angle A equals to 29.43 over 53.58. And here they go, they apply the inverse sine to both sides. And these two, they're inverses, so they cancel, and all you have left is angle A. And that's what this is here. Okay? And so when you apply that in a calculator, you get 33.32 degrees. But it doesn't, let's see, does it say why? All right, that doesn't say why they want you to use degrees. Sometimes they'll ask for the answer in both degrees and degrees in minutes. Okay, so from here you would have to go ahead and convert this 0.32 to minutes. Okay, so we have angle A is 33.32. Okay, and so for angle B, we would subtract that from 90. And notice, since we have angles A and C, to find angle B, you just use the Pythagorean Theorem. Okay, and round that to 2 decimal places. All right, questions with that? Okay, here we're given a right triangle with two sides are given, and the angles in degrees and minutes. Now notice they have a triangle here, and they give you the values off to the side. Okay, and we want to give the angles in degrees and in degrees and minutes. So here we have angle A. And I like to go ahead and put the values right on the triangle, right on the figure. 47.8 degrees, and side C, 89.6 centimeters. Okay, and we want to find all the angles and all the sides. All right, so what we're going to do is we're going to find side A first. Go ahead and find side A. All right, go ahead and do that. I'll give you a minute to think about it and work on that, and then I'll start putting it up there. Okay, we're going to go ahead. since this first one is in tenths, we're going to go ahead and round that off to the nearest tenth. So anybody get side A? You take sine of 47.8, which is opposite over hypotenuse, so that makes it A over 89.6. Multiply 89.6 to both sides, they cancel. And so that's 89.6 times sine 47.8. Okay, and does anybody get a number? Travis? Go ahead and give it a shot. Yes, that's right. 66.4 for side A. So this is 66.4, so we'll go ahead and put that in there. And we can, at this point, we can go ahead, we can do one of two things. We could either use cosine, or we can use the Pythagorean Theorem. Okay, well, let's use, I'm going to go ahead and use, I think cosine would be a little bit easier. Cosine of 47.8. Cosine is adjacent over hypotenuse. So that would be B over 89.6. So we multiply 89.6 to both sides. And so these two cancel. We get B equals to 89.6 cosine 47.8. So basically, all you got to do is hit second and enter, and then just change sine to cosine. And that way you don't have to change the numbers. And you should have gotten 60.2. Okay? All right, well, how do we get angle B? Okay, so we got side B is 60.2. Side A is 66.4. We have side C already. We were given that. Now we need to find angle B. Okay, how do we find that? Dylan? Right. 90 minus 47.8. And we get 42.2. But we've also got to find that. That's in degrees, right? But we also have to find it in degrees and minutes. So that's going to be 42 degrees plus 2 degrees times what? Well, if our conversion is 1 degree equals to 60 minutes, right? What goes in the denominator so that the degrees cancel? Sydney?
1.
Yeah, the 1 degree. So we're going to multiply 60 minutes times 2. So that'd be, so that's going to give us, so that's 0.2 times 60. So that's going to be 42, move this over here, 42 degrees plus, well, 6 times 2 is 12, so 60 times 0.2, that'd still be 12. Okay? So our answer here is going to be 42 degrees, 12 minutes. Okay? All right, questions with that? if they ask you to find angle A in degrees and minutes, then you do the same thing. Okay? But I think it's a little bit easier to go ahead and subtract the decimal from 90 and then find the degrees and minutes from there. That way you don't have to borrow 60 and all that. All right, questions with that? All right, and then let's see, angle B. Yeah, let's do that one. Now the main thing that I wanted to show you with this next one is that here's angle B. All right, that's 68.5142 degrees. Now, when the angle is on top like this, sometimes students can get confused as far as, you know, how things are supposed to look on the triangle. Well, you know, again, the side opposite angle B is always, you know, the corresponding side for angle B. So here, side C is 3579.42. So if we wanted to find sine, we wanted to find side B. Okay, how would we do that? Given what we what we have, Dylan. Okay, here's our ratios, right? Okay. Now, okay, I'll leave it up to you. You can find either side B, A, or side B. All right, what would you do? Okay. Sine. Okay, so sine of 68.5142. Okay. B over 3579.42. All right, good. Now what? Okay, multiply both sides. So this would be 3579.42 sine 68.5142 equals to side B. All right, good. So let's see what we get when we do that. 3579.42 sine 68.5142. Okay, and you should have gotten 3330.68. So we'll round that to point. Well, they used, let's see, they went 2 decimal places, so 0.68. Okay? So, yeah, this is a large number. This is 3579, so this is 3330. So it's, you know, that's a good number. That's relatively close. Now, how would you now from there you could use either the Pythagorean theorem or what would cosine angle be? Sydney?
Is it the 3579?
Okay, so here's cosine 68.5142 equals. Okay, so the 3579.42, is that going to go in the numerator or denominator? So remember now, cosine is adjacent over hypotenuse, right?
On the bottom.
Good. And what goes on the numerator?
B.
Well, now B, we're looking at, here's angle B, right? Is B adjacent or opposite? Opposite, right. What would adjacent be? A, right. Good. A over 3579.42. So you see what I mean about when the angle is up on top like this, it kind of throws students off and how they look at it. So that's what I was talking about. So you want to look at this in terms of adjacent is right next to the angle. Okay? A is right next to the angle. B is opposite. Okay? So you want to remember that when you're working on these. Okay? So I don't think we need to go any further with that one. All right, questions with that? Okay. Here's a different looking one. This one's kind of like on its flipped over. Solve the triangle. Okay, so here we have what's this A equal to 12.5? What is that? Angle or a side? Travis? It's a side, right? Side A. Okay, so that's 12.5. So we'll write that right on the figure there. And side B, 16.2. Okay? So let's say, now, let's say we want to find angle A. Okay, using our memory device. Okay, we like to have that. It's a good idea to have that off to the side for you. Okay, how would we find, given those two sides, what ratio, sine, cosine, or tangent, would you use to find angle A? Sydney? Tangent, good. Okay, so tangent, angle A, equals to what?
12.5.
Good. 12.5 over 16.2. Okay, now we're given the values, but we're looking for the angle, so now what do we got to do? Dylan? I'll give you a hint. We got to apply something to both sides. Well, if we knew what angle A was, we could go ahead and multiply 16.2, but we don't. So we have to apply inverse. We have to apply inverse tangent, right? Inverse tangent. Got to apply inverse tangent to both sides, right? And what happens to tangent and inverse tangent? They cancel, right? They're inverses of each other. So we get inverse tangent of 12.5 over 16.2. Okay? So let's see what that looks like on the calculator. Second, inverse tangent. 12.5 divided by 16.2. Okay? And we get 37 point, we'll call it 65. Let's see. It says to give the degrees in minutes, so yeah, we'll use 6.5. Degrees in minutes. All right, we'll call it 0.7 because that would give us degrees, minutes, and seconds. Still might. All right. So from here, that's angle A, 37.7 degrees. Okay. Now, how do we find angle B? Well, all right, we'll go ahead and leave it in decimals for right now and then change it to degrees and minutes in a minute. Okay, angle B. How do we find that? Travis? Right, subtract 90 from 37.7. Now, on your calculator, okay, when we did the inverse tangent, now see this figure right here? We could go ahead, I would go ahead and subtract 90 from that. So we're going to hit 90 minus, and then hit second and answer. Okay, 52.3. Okay, so yeah, that still comes out to be, you got to be careful when you round off that you don't get into this rounding off error. So it's better to get your angle directly from the calculator like this. That way you don't get in a rounding off error. Because if you did 37.7, this one happened to work out, 37.7 from 90. We still get 52.3. But it doesn't always work that way, so it's safer to go ahead and subtract it directly from the calculator and then get it. Okay? So, what did we say that was again? Dang it. 52.3. All right. Okay, so angle B, 52.3. So we go ahead, 37.7. So we take 37 degrees plus 0.7. Okay, so go ahead and convert that to degrees and minutes. All right, go ahead and do the rest of that. Okay, we get 37 degrees and how many minutes? 42, good. And so the other one, that's going to be 52 degrees plus 0.3 times 60 over 1 degree. And so we get 52 degrees. And so 0.3 times 60, and we get 18 minutes. Okay? And then the third side, how do we find that? We don't have to use trigonometry here. What can we use? Travis? What's that? We're trying to find side C. We got angle B, right? That's 52.3 degrees. So the only thing we don't have is side C. Okay? We got everything else. We don't have side C. So how do we find that? Pythagorean theorem, right. Okay? But Pythagorean theorem is c squared equals a squared plus b squared, right? What is your hypotenuse? That's always the side opposite the right. I see you guys calculating, so I know you guys know what that is. Okay, and so you can go ahead and apply it directly into the calculator just like that. Okay, so 12.5 and 16.2. So you could hit second and square root 12.5 squared plus 16.2 squared. And then close it. And then that way you just, boom, put it in there all in one shot. And you get 20 point, we're rounding to the nearest 10, 20.5. Okay? Questions with that? Okay. We've only got a couple of minutes left. Solve each triangle in each case. The C is the 90 degrees, is the right angle. Okay, now here they give you the angle in degrees and minutes. So let's look at B. I mean, that's something they don't, in this case, they did not draw out the triangle for you. But they did tell you that the right angle is is C. So you draw your own triangle. Okay? And whether you put A down here at the bottom or A at the top, that really doesn't matter. What does matter is that side A is opposite angle A, and side B is opposite angle B. Side C is opposite angle C. Okay? And then angle B is, we're going to do B, 39 degrees, 9 minutes. 0.09 minutes. 39 degrees, 09 minutes. Yeah, 39 degrees, 9 minutes. And side C, 0.06231. Okay, find side B. Okay, find side B. All right, go ahead and do that. Got a couple of minutes left, so we're only going to do the B problem. Should have used sine 39 degrees 9 minutes equals to side B over 0.06231. So you're going to multiply that to both sides. And since we have the angle, then we would just multiply both sides. The only time you use the inverse is when you don't know the angle. And you're going to use the second angle feature. I don't know if you have to use 0.9 on the calculator. I'm going to try just 9, see what happens. Did anybody use 9 instead of 0.9? I got 0.039339592.7. Is that what you guys? Anybody use 0.9? No? Let's see if it makes any difference. It probably won't, but sometimes you just don't know until you try it. Okay, it's the same. Whether you use 0.9 or just 9 minutes, 0.9 minutes or 9 minutes, the same. The answer is the same. So they went 4 decimal places, so that's where we're going to go. So this is 0.03934. That is 4. Wait, let's see. We went 4 places. Okay, so that is 4. 0.393. That looks. Oh, I see what I did. This should be 0.6, not 0.06. So that's probably going to move my decimal point over 2. Yeah, that's better. Okay, so we get 0.3934. That's better. Equals to side B. All right? And then from there, what would you do? To get side A. Dylan? You could use cosine, yeah. But what else could you use? You could also use the Pythagorean Theorem, that's right. And how about angle A? How would you find that? Right. Angle B from 90. So let's try that using degrees and minutes. So this would be 90, right? That would be 90. That's equivalent to 89 degrees, 60 minutes. We already know that. Minus 39 degrees, 09 minutes. Now this one, you do have to use the 0.9. And I see why they use 0.9. That makes sense. And so that'll be 1, 5, and then 0, 50 degrees, 51 minutes for angle A. Okay? All right, questions with that? Okay, and that is lesson 29.